I wish you guys could do the exercises instead of me, because I do think you learn more. But what I'm trying to show though is, the LIN master slave concept, and that each of the vSpice having their own set of function blocks and their own graphical panels and owns their own application signals. So that's good to hear. So now if I go back to the manual here, so we did this. We see that activity 2 is complete. I think this is a little bit out of order here. I gotta check my numbers here. So we did the exercise 3 was just opening up. Oh, okay. Oh, that's what I did wrong. So I opened up master exercise 3 already when I should have opened up just master and then slave and then slave. Okay. And then I kind of jumped the gun. Okay. So I apologize for that. So then we do 3. And now we're going to get a response back. Okay, so the only difference here, I think, is if I go to the slave and I run this function block. So I'm going to expand this a little bit. And then instead of manual, if I just make this immediate, so he runs. I'm going to restart him. Okay, so now, oh, I don't know if it took that. Okay. Sometimes when you make a selection, you got to click off of it for it to take. All right, now he's running. Okay, now I can go back here, go to messages, and then bring this down. Maybe show more of this guy. All right, so now I got them both running. Notice now we have the LEDs. Okay, everything is turned off. Notice we have the LEDs now responding back. So, or I should say the slave responded back with the button press. So the only difference here was, let me open up this one first. So this is the slave message coming back for the buttons and the temperature. And you'll see that the slave is responding true or false based on the button press. That's good. And then the slider value is changing. So now it's the master is sending it out, the slave acknowledges it, and then sends it back in another message. And then we update the display now accordingly. So that's our indication that the slave is responding, that we turn on the LED, and then we display the temperature over there and update it. So that's exercise number 3, basically. And then the only difference was then on the function blocks were turned on the slave. And if I stop that and expand this, I think before I send this out to you, I'm going to update the file and add some comments in the comments section. But you'll see that in the slave side, I don't have any application signals. There are no application signals. I'm going to move that over there. Okay, so then how is this working if there are no application signals? So what I did was the set value right here, this button press defrost ACK, this is my acknowledgement, and I'm just using the signal I received from the master. So if I double click on this, the value to set is the button press defrost ACK, okay? And that is in my transmit message right there. So button press defrost ACK right there. So that's what I'm trying to set. And then what am I putting in that is the button press defrost that I received from the master HVAC unit. So it's now that signal. So in this scenario, I didn't use any application signals. I basically copied what the master sent me and put it back into another message and returned it back as the acknowledgement. So that's one way of doing it. There are no application signals. I could have done application signals. I would have had to copy it to an application signal, and then I would have had to copy the application signal back into this message. The only thing when you're doing this is when you're doing this set value, let me pick another one here, fan medium. Just remember that, okay, value to set is in the transmit message. So fan medium ACK, and then the expression is in the receive message. So you got to go back and forth. Sometimes you'll end up forgetting to go back and forth or click on the right one first, and then your system isn't working. Well, it's because you have a typo in how you set this up. So just remember that. So that's lab 3. Excuse me, let's go back to the Word doc. So now we have acknowledgement on the from the slave. So we light the LEDs that they saw the button press. And we see it in the messages, and we see it down here in the button press acknowledgement message. So what changed is I ran that function block in the slave side. So that was activity 3. So activity 4 now is load in training master exercise 4. So let's do that. So file, open, I'm not going to save my changes. Master 4. And then on this one, and then I can go ahead and just run it. It's the same thing, but now we're going to add a fan override. So run with transmit 6.9. We can see we've added another message, number 13. So we had 10, 11, 12, and now we added 13. And then same on this side now, file, open. I'm not going to save my changes. I'll fix this and clean it up before I send it to you. Slave 4, exercise 4. And again, see how it remembers the last state? I don't like that. So I want to initialize everything and set this to 0. So run with transmit 89. Okay, so now I got messages coming back from the slave. And so I should be able to click on these buttons and I get the acknowledgement back, and you can see it on the slave side. Just double check all of them. And then verify the temperature is working. Okay. So I'm going to shut these off here on the bottom. So what is this fan override that I added? So it's another message. So the if I go to the message editor and I look at the transmit, it's number 13, master header fan override. It's a header only. And then on the receive side, it's a fan override. And if I look at the signal, it's just one bit signal coming back, okay? And then if I go to the slave side, I go to the message editor, I go to the receive table, I'm already there. There's the fan override. Again, remember, this is coming from the master, so it's a header only. There are no signals, but I am going to send out the slave data fan override when I receive the master header fan override. So if I go to the transmit, and now I made the color green, fan override. And if I go to the message view on the slave side, I think I gotta scroll down here. Yeah, so sometimes you get this error. You can hit the erase, when you're first starting out, there's sometimes an error. I'm not sure why that is, but you can see I have the 11, 12, and 13 messages. And if I want, I can expand each one of these. on the slave side. Okay, so the fan override is false right now. And so I have a button on the slave side I added called fan override. And the whole idea behind this is I'm thinking more of a front seat, back seat scenario in the vehicle. So in the back seat, you want to have your own fan control. So let's say I do a fan override by clicking on this. The master sees this, right? So now he knows that the back seat is going to have control of the fan. And now when I press these buttons here on the master side, notice I don't get any acknowledgement back. And that's because I'm in a fan override mode right now on the slave side. So the slave side is controlling the fans right now. And then another thing I want to note here is in a real world situation, you can have the fan off and on at the same time and have it running low, medium, and high. So ideally, there should be a function block script that would control that if I clicked on low, then the medium and high cannot be turned on. If I was on low and I clicked on medium, I would have to shut low off and high off. But right now the way it's set up is I can click on, if I take the fan override off, I can have all of them turned on at the same time. So in a real world situation, that wouldn't be true, but this is just a demo. I just wanted to show that, hey, we have an acknowledgement back from the slave. And if I go to fan override, as soon as fan override comes on, I probably should turn these off as well, right? So these should go off, and then I should have no control over these buttons. So that was really lab 4, was going into the fan override. And all we did there, like I said, was we added that message, and then we to the transmit and the receive side of things. And we're running those 2 scripts on this side. So that was lab 4, exercise 4. I had, and the reason I came up with this scenario here at Intrepid, when I worked at Microchip, I actually created a circuit board. I was on the capacitive touch team. So all of these buttons were capacitive touch on the circuit board, including the slider. So I had a master node that did the capacitive touch and the LIN communications. And then I had 9 slaves. And each slave was a little microcontroller and a LIN transceiver. And then it had an LED on the slaves that would turn on when the capacitive touch button was pressed. And then it also would send acknowledgement back up to the master that that it acknowledged that the button was pressed. And then for the fan, what I did is I had a fan mounted on the circuit board, and I had some circuitry there to control the fan. And so I had the control for off, low, medium, and high. And again, you could only do one of the 4 buttons were active at a time. And then for the override, I actually had on the slave side, which I did not include in this lab, but on the slave side, I then had 4 buttons to control the fan. So first you had to do fan override, and then I had its off, low, medium, and high fan speeds. And so when I would press those, it would control the fan accordingly. So I taught a LIN class there. It was pretty cool because everybody got to play with the capacitive touch side of things, as well as learning LIN and combining LIN with real world applications. So a lot of times in our capacitive touch demos, we just had a capacitive touch board and then it would have an LED above the pad, and it would say, okay, yeah, you touched the pad, big deal, but I want to do something with it. So now I had to combine the capacitive touch library with LIN, with our LIN library or LIN code for becoming a master or a slave. So that was a pretty cool exercise. And again, that was a half-day class. So I kind of took that same concept and I brought it into here without adding the complexity of adding the buttons into the slave, because I don't think we could finish. If you guys had to do all the labs without me showing you this, I think it would take the full 4 hours. And so this way we kind of limit what we're doing in the labs. But that was the whole concept behind this lab, was that capacitive touch LIN board I did add microchip. Okay, so that's it on exercise number 4. So now I'm back on the master. And let's go to function blocks. And I think that was actually in the handout as well. This is the problem when you start resizing things though in vSpy. There we go. Okay, now I brought this back. Bring this down. And then why am I not seeing it? What am I doing wrong here? So LIN training master 4. Yeah, so there's the application signals, message editor. So if I bring up the Word document, okay, I have an if statement in here, end if, right? And I don't see it in this one here. So I got to figure out why it's not working. But if we look at this document here, and let me zoom in on this and bring this over. Oh, it was added to the slave node function block. Okay. So if I go to the slave node side of things, I guess I could have added it in either case. So in the slave node, I added the if there. So remember, I would acknowledge, when I acknowledge back to the master, I would just take the signal from the master and then put it into the LIN signal of the other message, right? But now I added an if statement that if I have the fan override set to 0, if it's set to 0, I would allow those messages to go back to the master. And if it was set to 1, then I would not acknowledge back to the master. So that's how I did it. Does that make sense to you? So in this fan, yeah, so one thing about our scripting language is, notice this is an application signal, button press, fan override. And you can see the state is false right now, right? And if I press it, it's true, okay? So if I don't press it, I don't have a fan override, then if this is false, if it is equal to 0, go ahead and process these steps where I acknowledge back to the master that the button was pressed. Or if it's not pressed, go ahead and acknowledge back to the master that it's a normal condition. If the fan override is pressed, then don't acknowledge these messages back to the master, right? So now if I go back to the master, the only time I would light these LEDs is when I got an acknowledgement back from the slave. So that was my logic. You could have put the logic in the master side as well. If the fan override button was on, right? You could say then don't light the LEDs. So that's another way to do it. Go back to the manual. Okay, activity 5, last one here is the LIN LDF file. And so what we're going to do is we're going to actually choose a different logon name, and then the platform is going to be LIN LDF exercise as well. Then after that, we're going to load in an LDF file, and we're going to do that like we do a database file, and then we're going to create a schedule table. So let me go ahead and stop this and stop this as well. And I'm going to bring up a new instance of Vehicle Spy. And we're going to go to LIN LDF exercise and LIN. All right. Then go back to my message editor, function blocks. Okay. So this is it's empty right now. Okay. So if I go into the LIN LDF exercise, I click on this just like we do when we're going to load a database file for CAN. I've already set up the platform and I called it LIN LDF exercise. And then I'm going to come down here and expand this for LIN. And then I'm going to select LIN 1. Of course, I can have different LDF files for the different LIN buses. And so here's training LDF file 5/31/2018. And next we're going to click on create schedule table function blocks. But before that, I'm going to open this up in the LDF tool just to view it. So you can see this is an old file. I think this is one we used in our previous training class. So it's LIN LDF version 1.3 running at 10.41. There's a training master with the 5 millisecond time base, and we allow 1 millisecond of jitter. The slave nodes, there's only one slave node, training slave, and then there's no signals, and there are some frames here. There's 4 frames. So there's the ID for each frame. So 31, 32, 33, and 34. And then 50 milliseconds apart. So I'm going to open up another LDF file that's more current than this, but I just wanted to show this to you first, and then now create the schedule table. And we'll default to training master. So those are the 2 nodes in the LDF file, and it says it was created. Now if I go to function block, so here is the name. It defaults to schedule table 1, schedule table, and then it's manual. So you have to change this to immediate in order for it to start automatically. Click off of it. And then if I bring this up, there are the 4 transmit messages with a 50 millisecond delay between messages. Okay, and if I run this, and I go to the message view. Okay, so here we go. I'll go to LIN for the layout. And we can expand these columns by dragging this up. So no slave data, okay? Let's go to the Word doc. So we did this. Whoops, didn't like me hitting that control key a couple times, okay? Training master, scripting table, that was the name, and then the manual, change that to immediate. Okay, now in the message editor, there's a typo there, okay? Select LIN network and then transmit button. Okay, so now in this case, it's a little bit different than when we did ours. So LIN, okay, so now we're on the LIN and we went to transmit table And this came right from the LDF file. So we have training slave response 31. And the reason I don't like this is training slave response 31, but it's a transmit message. I don't know, this doesn't make sense to me, but anyway, let's go back to the Word doc. So we open up the message editor. These are the 4 messages. It does say header only. And then we're going to change these to embedded only, okay? And the reason we're going to do that is notice we have duplicates of the messages. So we have 31, 32, 33, 34 twice. And we're showing that it's being transmitted out of the computer and out of the Fire2. So let's go back to message editor and click on each one and then change this to embedded only. Did I miss one? Yes, I did. Okay. All right, so now we have the 4 messages, but we're not getting a response back from the slave. Go back to the Word doc. Okay, did that. Okay, open up another instance of vSpy. Okay, now when we do that, it remembers our last logon name and last platform, which is good because now I don't have to select those again. So because it remembers, because we were already pointing to that, basically that LDF file, that we can go ahead and look at the database. And then what we're going to do is we're going to copy those 4 messages to the receive table. And we're going to copy them to the transmit table. Okay. And then we're going to fill in some data bytes for the 4 messages while in the transmit tab. And we're going to assign some colors. So remember, we're on the slave side of things now, right? So message editor. And then there, if I go to the database, but again, I got to go to LIN. So there's those 4 messages. There's nothing in the transmit. There's nothing in the receive. So I'm going to click on the first one, hold down the shift, click on the 4th one, right click my mouse, copy to receive, and then do the same thing, copy to transmit. Now I'm going to go to the transmit table, and it said to put in some data bytes, 1, 1, 2, 2, 3, 3, 4, 4. I don't know, whatever. And then give it a color, right? So purple, green, blue, red. Okay. Go back to the Word doc. Okay, so we did that. Make sure I didn't miss a step. So we did a copy to, says slave, and we did that. Okay, the next thing we want to do is go to the receive table. And just like we did in the other one, we're going to select the transmit message in the receive table. So whenever this message comes in from the master, we're going to transmit this message back out on the bus. And that's why I don't like this lab, because it's the same name, which is okay, I guess, but it's just sometimes a little confusing. And then also we want to click on this ignore TX messages on the slave side so we don't have duplicate messages. So now I'm going to go to the receive table. I'm going to expand this column for TX messages, double click. We're going to do LIN, click on the first one, click on the 32, click on the 33, click on the 34. And then we have to select ignore TX message on each one of these. All right, next thing is I think to hit start. Okay, so now we should see valid LIN messages. So run with transmit 89. This is the highest denominator one. And go to the message view, erase the buffer so we're clean, and there we go. So, and I can go ahead and select LIN down here as well. So we are transmitting as a slave, right, these 4 messages with these static bytes, okay? And if I go back now to the master, we didn't color code any of these messages, I don't believe. No, we didn't color code any of these, so they're black. But you can see now we are getting messages back from the slave because these were header only messages. We know that from this LED in the transmit header column. And then it's the slave that's responding with this data. So this is just another way of doing it with an LDF file. And then I did want to bring in one more LDF file to show you. So if I open up one more instance of eSpy and I go to setup, LIN, and now I'm going to browse. And now here's a, that was, I think that was 531. Yeah, so I'm going to open up 8.2. Save the platform change, which I'll have to go back and put the old one in. And then open an LDF tool to view it. And notice on this file, it's LIN version 2.1, still running at 10.4, but a lot of times you will see 19.2. Master node now is my master HVAC. And here are my slave nodes. This is what that circuit board that I created I was talking about. So I had 6 slaves. So I had 6 slaves and 1 master. So I had 7 microcontrollers on the board, 7 transceivers, 9 capacitive touch buttons on the master, and 4 more on the slave. And if I look at the signals, so these are the signals that for all the messages. These are the frames with the signals within each frame. So what is it putting back? So the master was just sending out 2 bytes. And then there's the frame size on each one of these. Yeah, so these were 1 byte responses. Schedule tables, so 10 milliseconds between messages. If you had any encodings, I don't. And then the LDF file itself. So here's the master HVAC. Here are all the slaves defined. All the signals I created. And then the frames, how they would go out on the bus, right? And then all of the IDs. And then here's the final schedule table at the bottom. So very simple, no diagnostics or anything like that, but a little bit more up-to-date LDF file. So that's all I had today. I think that was it for the documentation here. Yep, activity 5 is complete. So I know we went a little fast, but we would normally have another hour to go. if you guys were doing this yourself. So, or even more than that, we're ended pretty quick, 11:20.